In this tutorial, I'm going to show you how to draw Lewis dot structures. Let's begin. Alright, so you are going to get this from the guest teacher today. This is a little glue-in that we're going to put into our Cornell notes. And so imagine that you have a notebook and it's going to go right there, kind of up against that line that we draw where we put the questions. And then we're going to write some stuff down next to the right of this little glue-in thing. All right, this is all going to happen on page 11. All right, so let's get started here. Let's get this thing a little closer. Let's talk about the octet rule. All right, so the octet, first of all, the prefix oct refers to the number 8, like octagons have 8 sides to them. So there's a lot of exceptions, especially hydrogen. Hydrogen doesn't care about 8 electrons. But the octet rule is many electrons will want, atoms will want to have 8 valence electrons in their outer valence orbitals. And how do atoms do that? Well, atoms are going to gain 8 valence electrons by sharing or transferring electrons. And when they share electrons, it's all about those covalent bonds. All right, so that's the information about the octet rule. Let me go to a new screen here. What we're going to do on the right-hand side is, the right-hand side of our notes, is we're going to draw the Lewis dot structure for CH3I. And in order for us to do this very first step, is we will need to figure out the number of valence electrons for each atom. All right, so using your periodic table, that's how you're going to do this, right? Using your periodic table, let's find carbon on our periodic table. We're going to forget about the D block, all those transition metals in the middle. We just care about the main group elements. Okay, so there's carbon. Let's count over from the left. We're going to skip the D block. 1, 2, 3, 4. Carbon has 4 valence electrons. What about hydrogen? Hydrogen is in the first column, so there's 1 valence electron for hydrogen. And let's see, where's iodine? Iodine is all the way on the right. We're going to count over from the left. Remember, we're going to skip those elements in the middle. And let's see, 1, 2, 3, 4, 5, 6, 7. Iodine has 7 valence electrons. Okay, so we have the information. We just did step number 1. Let's just write those out again, though. So, looking at the chemical formula, determine the number of valence electrons for each atom. Carbon is 4, hydrogen is 1 each, and iodine is 7. All right, step number 2, we're going to write the symbol for each atom and place a dot around the symbol, 1 dot for each valence electron. For carbon, since it has 4 valence electrons, it's going to have 4 valence 4 dots rather around carbon. And when you draw them, you're going to want to draw them, never pair them on any side of the carbon until you need to, I guess. So leave them unpaired until you can no longer leave them unpaired. I'll show you what I mean in a moment. So carbon's got 4 dots on the outside. Let's see, hydrogen, let's draw 3 of those. It's got 1 dot each, 1 valence electron each. Iodine, and there's 7. So that's what I'm talking about. You can't pair up those electrons until you don't have any choice. So iodine has 7 valence electrons. We'll start to pair them up right there. Notice how there's 1 unpaired valence electron on iodine. All right, hopefully this is not too confusing. Step number 3 says figure out the central atom. This is usually the atom with the highest valence number or the lower electronegativity. So you can use that chart in your notes if you need to. Look at these little kind of A and B down here. Hydrogen and the halogens, that's fluorine, chlorine, bromine, and iodine, are never the central atom. Carbon is usually the central atom. So this is going to be really easy for us today. Carbon is a central atom. Let's write that down. Carbon's the central atom. I've got to switch to the next slide here so we have some more room. Let me just draw this out real quick. And we'll do the last couple steps. So there's carbon as the central atom. Perfect. All right, now what we're going to do is create bonds by pairing atoms with unpaired valence electrons. Carbon has 4 unpaired valence electrons, so we're going to just start to add in those other ones. Let's draw carbon right there in the middle because it's the central atom, and then we'll start to draw our hydrogens in. Hydrogens bring their 1 valence electron, and notice how that Hydrogen is sharing its valence electron with carbon, just like carbon is sharing its valence electron with hydrogen. Let's draw the next one. Okay, well, what about that iodine? Well, we have one extra spot left over for that iodine, so we're just going to plop it right in there. Notice how those extra lone pairs of electrons stay with iodine. That's kind of important. All right, so now the next step is erase the paired electrons and draw a dash representing the bond. We're going to do that for only the ones that are being shared, not the ones around iodine, right? Erase, draw in, erase the two that are being shared between carbon and iodine, and then draw in a bond right there. Okay, but notice please, step 6, leave any lone pairs of electrons. Do not erase those. Look at the ones on iodine. I leave those. This is the finished answer right there. I want to do a couple more problems here so that you guys fully understand how to do valence, how to draw Lewis dot structures. So let's try another one. Oops, yeah, notice how those are there. Okay, so now let's try, how about fluorine gas, F2. All right, so looking at the chemical formula, determine the number of valence electrons for each atom. Fluorine, just like iodine, is 7 over from the left. So there's going to be 7 valence electrons. Since there's 2 fluorines, I'm going to draw F and F twice. And I'm going to draw 7 electrons surrounding each one. This time I'm going to use different colors so you can really see the sharing, I suppose. Okay, so we just did steps 1 and 2. Step 3, there's not a central atom. So we're good with step 3. Let's go down to step 4. All right, so what you're going to do is create bonds by pairing atoms with unpaired valence electrons. Look at those yellow and red ones that's being shared between the two F's. That's that bond. Step 5, erase the paired electrons and draw a dash representing the bond. Leave any of those lone pairs of electrons. Do not erase those. So we're going to leave the red and yellow ones there. All right, step 7 we're not going to get into today, so don't worry about doubles and triple bonds right now. All right, let's try, how about we try BR. Oh, you know what, here's what I'm trying to explain with this. So how do you write those dots in? So you have to kind of imagine that there's this imaginary box that is around each of these atomic symbols. And then you start to add in those dots one at a time as if you are filling in this imaginary box. So if you needed to practice, you kind of make a little box around there, and then you can try to erase it, and you're left over with those perfectly drawn electron valence dots. Okay, moving forward, let's do another example. How about we try to do NBr3? Okay, so looking at the chemical formula, determine the number of valence electrons for each atom. Nitrogen is 5 over, so it's going to have 5 valence electrons. Br is 7 over, so it'll have 7 valence electrons. We're going to write out each component of this. I'm going to draw in those 5 valence electrons on nitrogen. I'm going to draw in those 7 valence electrons around each of my bromines. Okay, so figure out the central atom. This is usually the atom with the highest valence number or the lower electronegativity. Hydrogen and those halogens. Hey, Br is a halogen, so it's never the central atom. You know what? That means that nitrogen's got to be. So I'm going to put nitrogen in the middle, and I'm going to start to put those Brs around. Notice how there are some electrons that are being shared. Create bonds by pairing atoms with unpaired valence electrons. Step 5 is for us to erase and draw a dash representing the bond. Let's do it again. And draw. And draw. So that is how you draw very simple Lewis dot structures. I have a handout with 9 questions that I'd like you guys to work on. After you're finished with those 9 questions, I have some more practice problems in the textbook. So ask the guest teacher exactly what you're supposed to do, and I'll see you all on Monday.